Hello everyone, Bhavya here. You are all welcome to the basic machine learning workshop conducted by Cynaptics Lab. Today is the day one of this workshop. So basically what is machine learning? Let's discuss about it. So as the name suggests, machine learning in machine learning we basically try to make the machine learn to solve problems and when we give some data to it. So this is the basic thing. So now let's first differentiate between what's traditional programming and what's the machine learning. In traditional programming, we feed the data and the program to the computer, and in return, it gives the output. So whatever you code in C++ or something, so basically you write a program and you give the input data, and the computer gives the output. So that's the traditional programming. Now, if we consider the machine learning, so in machine learning, we feed the data and we have the corresponding output. And these things we feed to the computer, and the computer in return creates a program or algorithm or formula to map the data to the output. So basically, it creates that program or algorithm, and after that, if we feed some new data into it, then it gives the predictions. So that's what machine learning is. That's how machine learning is different from traditional programming. So now look on the what's the definition of machine learning. So basically, machine learning enables a machine to learn automatically from the data and improve performance from experiences and predict things without being explicitly programmed. So basically, in this, we just feed the data and the output, and we don't program anything else. It automatically creates an algorithm and program and to map the data to the output. And finally, if we feed some new data to it, and then it gives its predictions. So that's what machine learning is. And here our primary aim is to allow the computers to learn automatically without any human intervention or assistance and just actions accordingly. So basically here we are trying to make the automation of computers or machines to think like to solve problems like humans. So that's what machine learning is. So here is the how basically the machine learning works. So machine learning, as you can see, firstly we feed the input data to the machine, and when we feed this data to the machine, this is known as training. So now the machine, what machine does here is that it learns from the data. It either maps the data to the output or creates some logic like how the data is related to itself. So it creates an algorithm on the basis of our input data. So that is known as training. And after training, basically it creates a model. It creates a model to it creates a model from the input data. So after the model is created, if we feed some new data into it, then using this model, it gives us the corresponding output. So basically, this is how the machine learning works. So basically, we feed the data, that is, we train it. While training, it creates a model. Then if we give some new data to it, it gives the corresponding output. So this is how machine learning works. Okay. Now this is the very interesting question you must all have in your mind. Like, what's the difference between artificial intelligence and the machine learning? So let me clear this. So my artificial intelligence is a bigger set. So artificial intelligence, we uh, try to make the machines mimic like human behavior. We try to make them think like humans to solve problems like humans without being programmed. So artificial intelligence is a bigger set. Machine learning is the smallest set of artificial intelligence. So basically, in machine learning, we feed the data to it. Then the machine uses some statistical models to map the data and its output, and in return, it creates an algorithm. So basically, this is what machine learning does. So basically, machine learning is a subset of artificial intelligence. Now, the another subset of it is the deep learning. Deep learning is basically it uses the neural networks, so which is similar to the neurons which have in our brains. So it works very similar to how the humans think. So as the humans have neurons, similarly the deep learning has a network of neurons in order to make the machines think like humans. So this is the difference between three. Like artificial intelligence is a bigger set, then the subset is machine learning, and its subset is deep learning. Yeah. Yeah, so here's the difference. Basically, artificial intelligence is a technology in which enables a machine to simulate a human behavior, that is to think like humans, to solve problems like humans without being programmed. And on the other hand, machine learning is a subset of artificial intelligence which allows a machine to learn from the data without being programmed. So basically, in machine learning, it learns from the data. And if we talk about the goal of both of them, then the goal of artificial intelligence is to make smart computers which can solve problems like humans. And if we talk about the goal of machine learning, is to allow the machines to learn from data so that they can give the output for the new data. So in this way, artificial intelligence and machine learning are different from each other. Now, some very interesting applications of machine learning. Okay. The first one is image recognition. You all must have used a Facebook, and in that you must have noticed that there is an automatic friend tagging suggestion in it. So if you post a photo on Facebook, then it automatically suggests some. It automatically recognizes faces and gives suggestions that this person is this. So that is the automatic friend tagging suggestions, which is on Facebook, and this also uses machine learning algorithms. Second one is face recognition. So face recognition, you all must have is seen in your mobile phones and or devices. You can unlock your phones using this. So this also involves a machine learning algorithm. So second one is speech recognition. Some famous examples of speech recognition is Google Assistant, then Siri, Alexa, and Cortana. So basically, in speech recognition, the machine detects what we are speaking, and in return, it answers to our questions. And this problem also involves the machine learning algorithms. Third one is traffic prediction. The famous example of traffic prediction is Google Maps. Suppose, for example, you want to go to a destination and you typed it in your Google Maps, then it shows you how much time it will take you and how much kilometers it has. So this also involves a machine learning algorithm in order to find the like how is the traffic there, how long will it take for you to go there, and also so all of this involves the machine learning algorithms. And the fourth one is product recommendation. So famous examples are Amazon, Netflix, and YouTube. So for example, if you buy something on Amazon or you watch some series on Netflix or watch some videos on YouTube, so it keeps a track of all this, and the next time when you open these apps, it suggests use some related products or related movies or web series or related videos. So all of this also involves a machine learning algorithm. And the fifth is advertisements. Advertisements like you can on YouTube, on Facebook, and on Google. So if you watch some videos on YouTube, then next time you open it, it suggests you some ads, advertisements related to the videos you watch. Similarly, on Facebook, the post you like, whatever post you like, the next time you open the app, it shows the similar post for your convenience. And similarly on Google. So all of this also involves some machine learning algorithms. So these are the some of the applications, very interesting applications of where the machine learning is used. So this was basically what machine learning is. Now my friend Parth will dive deep into what is machine learning and its various types. These are, you can see the basic ML frameworks which can be used, which are TensorFlow, PyTorch, and Keras. Yes, Parth.
Am I audible? Yes, Parth, you're audible. Yes. Hi everyone, I am Parth Bhore from second year CSC. So now, just now Bhavya explained what is machine learning, what is AI, and different applications of machine learning. So now I will discuss some different machine learning algorithms. So first thing we should know is what are the different types of machine learning algorithms. So yeah, algorithms are mainly classified into three main classes. That is unsupervised learning, supervised learning, and then reinforcement learning. So here in this diagram, you can see that again they are subdivided and all. But first we need to focus on these three. So first you should understand what is unsupervised learning, what is supervised, and what is reinforcement learning. So I will explain them one by one. So again, this graph shows the same, these three categories, and then again there are subcategories. Now let's come to supervised machine learning. So in supervised machine learning, the data that is given to the program or the model, it is labeled. So and using the data and the label, a relationship is established, and a model is created. So first you should know what is the label. So look at this picture here. So here a model training picture is given of supervised ML. So and this you can see in green box, hexagon, triangle, and square. So these are the labels. So what is the role of the labels here? So using the labels, you can identify what type of data it is. So so the computer, the program will know that this is hexagon, this is triangle, and this is square. So this is the role of the label. So using that, we can the program can identify that and classify the data into different categories, and using that, a model can be established. So and program. So once a model is programmed, then we can give different test data. So once we give it test data, then it can predict using the model that whether it is a square or triangle. So this is the role of the labels. So once we have the labels, then using that labels, the model is trained, and using the model, then we can predict whether it is a square or triangle or any other shape. So so basically, the machine learning yeah, on label training data, it is known as supervised machine learning, because the model is trained under the supervision of the labels. So and this is the you can also see the formal definition here. So I will just read it once. That supervised learning is the machine learning task of learning a function that maps an input to its output based on an example of input-output pairs, and it infers a function from labeled training data consisting of a set of training examples. So as you saw, using the labels, we classified the data into three different shapes, and once the data is classified, then we can use different our test data to predict different shapes. So once it gives a square, then we can our machine learning model will give us a square, and same for triangle and all. So this was a simple example of supervised machine learning. And then now again there are two subcategories of supervised learning. So one is classification and one is regression. So here I will just give a definition because we will explain in detail later. So so what is classification? Just now I explained this is an example of classification. So here you divided the data in three categories: hexagon, triangle, and square. So you have, when you have to divide the data in two or more categories, usually two or three, or maybe sometimes there may be 5 to 10 categories also. So it is a classification problem. So there are some finite number of categories, and you have to divide the data into it, and you have to predict whether it belongs to this category or that category. So that is known as the classification. And next subpart is regression. So so it is different from classification, and here there is no finite number of classes. So for example, you have to predict some prices here. So let's say you have to predict some house prices. You have been given some house price data, like different features of a house, such as land and number of rooms and all, and you have to predict its price. So and price is not a you can't define it in a class. So price is continuous. It is and in a way it is infinite. So So when we give some features of the house, then we have to predict its price. So what would be its price, estimated price? So such a problem is known as a regression problem. So this was the classification, and this was a regression, but we will talk about it later. So these two come under the category of supervised learning, and I will just explain again. So in supervised learning, we give them some labels to train with the data, and using that labels, a supervised machine learning model is trained. Yes, we can also elaborate ML frameworks at the end. So now, just now we saw classification and regression, these two categories, and now we will see some types of machine learning, some more types of supervised machine learning algorithms. So one such type is a decision tree. So what happens in a decision tree? So a dataset consists of a different parameters. So using that parameters at each node of a decision tree, a decision is taken, and the parameters are split. So at each node, the parameters keep getting split until we reach the leaf node, and the leaf nodes are our results. So using the decision tree, we can again predict and give an estimate of the different parameters here. And now we will talk about random forest. But sometimes a single decision tree may not be enough. So, like using a single decision tree, we may not get enough accuracy of the model. So, in order to improve the accuracy and performance of the model, we may use multiple decision trees and then take their average, randomize them. So, using such an algorithm is known as random forest. So, instead of using a single decision tree to get an output, we use multiple decision trees, and it is known as random forest. And what is leaf node? Leaf node, it does not have any childs or children. So a leaf node is basically our result. So at the end, when we reach the leaf node, we reach a result. And in the decision node, a decision is taken, like whether we have to go to the left or go to the right, according to the parameters. According to the parameters, the decision is taken, and ultimately we reach a leaf node. Yes, like a dead end. Yes. So using the decision tree, we get our output. So so different leaf nodes will have different outputs, and according as the parameters will vary, we will reach the different leaf nodes. So this is known as a decision tree, and in random forest we use multiple decision trees. So it randomizes and averages different results, and we improve the accuracy of our model in the random forest. And then again, using either majority voting. So like what is the result of the majority of decision trees, or either directly averaging the different results. So we get using that we use the random forest. And now third is the naive Bayes algorithm. So naive Bayes algorithm is based on the Bayes theorem. All of you must have learned about the Bayes theorem in class 12. So using the Bayes theorem of conditional probability, the different their probabilities are calculated, and all the parameters are considered equal in Bayes theorem, in Naive Bayes algorithm. And using that, their probabilities are calculated, and using their probabilities, the model gives this output and prediction. So these were different types of supervised learning algorithms. So decision tree, random forest, Naive Bayes, and as you saw, classification, regression also. So now, so we just now talked about supervised machine learning, and now we will talk about unsupervised machine learning. So here there are no labels. So in the previous case, as we had labels, but here we don't have any labels. So how will the machine learning algorithm work now? So here you can see the basic understanding. So machine learning works with some pattern recognition. So what it will do, it will identify some pattern in the data. So, for example, you give the machine learning algorithm some images of dogs and some images of cats. So it is a mix of cats and dogs. And now you want the algorithm to predict whether it is a dog or cat. So how will the algorithm work? So first it will identify some features. So it will identify some features that are specific to the cat and identify features that are specific to the dog, and how it will identify those features using some pattern. So all the dogs will be similar in some way, and all the cats will be similar in some way. So using them, it will identify their pattern, and once the pattern is identified, then it can divide the dogs and cats into two categories. And this is the first category and this is the second. So using the first and second category, and then when we give it some test case, like when we give it a new image and ask it to whether predict whether it is a dog or a cat, then it will compare its features, like whether the features of the image matches with those of dogs or whether it matches with those of cats. So and whatever it matches with, and it will identify the image whether it is a cat or a dog. So this was a very simple example of unsupervised machine learning algorithm. So I will also read a formal definition once. So unsupervised learning is a type of machine learning algorithm used to draw inferences from datasets consisting of input data without label data. So there are no labels here. The most common unsupervised learning method is a cluster analysis. And now I will show what is a cluster analysis in the next slide. So here, uh, just look at the left image first. So here you can see there are three groups. Uh, we can see 1, 2, and 3. Three groups are there. So what the algorithm will do is it will find some similarities. So as they are nearer, so they will form three groups. So this is the first group. So here you can see after image, it is divided into three groups: green, blue, and black. So so it will so you can see as they were nearer, it divided into three groups: 1, 2, and 3. So using some similarities, and this is known as clustering. So it so that our data was divided into three groups or three clusters. So and here and this algorithm is known as KNN or K nearest neighbor. So I will again start what is KNN. So it will look at the nearest neighbors. So you can see, so it will look what are its nearest neighbors and are they similar. And using that algorithm, using whether they are similar or not, it will divide it into groups. So and ultimately, a number of k means a number of groups. So here k is 3. So because we have divided into three groups, so here k is 3, 1 to 3 clusters. And now you can also see the animation here. So here in the animation, first the circle is there, and then it checks in the neighbors. So whether it should be a triangle or a square. So as you can see, in the a circle is drawn of its neighborhood, and in the neighborhood there are four triangles but only three squares. So you can, once there is a pink circle, you can see. So the circle encloses four triangles, but it encloses only three squares. So since there are more triangles than squares, we will classify it as a triangle. So similarly, in the left image, if we get a new dot here somewhere here, so if it is closer to a black dot, then we will classify it as a black. It as a class of black class. And otherwise, if it is closer to the green part, then we will classify it as green. So since it is related to neighboring distances, it is known as k nearest neighbors, and where k stands for the number of groups or the number of clusters. So again, K means clustering, KNN. So these are different. So they all are based on the similar concept, but they just differ in implementation. So we just saw this example of KNN or K nearest neighbor, and using the pattern, we first and classified them into classes, and afterwards, whenever we want to test, we can test. We can see to which group it is closest to, and using that we can classify it in a group. So this was the KNN. So now we will look into the new third category. So third one is reinforcement learning. So this is a fairly new algorithm. And what does reinforcement learning means? So reinforcement learning is a type of machine learning method where an intelligent agent interacts with the environment and learns to act within that. So here there is an intelligent agent and there is an environment. So first, what is an agent and what is an environment? So here you can see the definitions of agent and sorry, examples of agent and environment also. For example, an intelligent agent may be an AI robot, and we want to train that AI robot. So that robot is our intelligent agent. And what is an environment? So wherever the robot is present, such as in a room, yeah, such as it may be in a room, or it may be in a football ground or a maze. If you want to make a maze solver, then the environment will be maze. Otherwise, if you want to teach the robot football, then it will be a football ground. Like that, there will be an agent and there will be an environment. So and there will be interaction between the agent and the environment. So what does the interaction means? So it will the agent will try to learn about its surroundings, about its environment, and take decisions to maximize the reward. So what is reward? So if the for example, we want to solve a game using AI, so the reward will be to win the game or to win that level. If you want to develop a model to beat Mario, so you can see if the Mario corrects points, or if the Mario wins the level, then it will get reward. So using that, and if it loses, then it will yeah, again. So using that, if it wins the level, of it wins the game, then it will get reward. And using that reward, uh, we train the agent to win the game. So this was an example, like solving different. You can see in examples also solving different games like Mario. From many different types of games have been solved using reinforcement learning. So like Mario and chess are just two examples. So in chess, the combat AI plays many games of chess and learns different methods and tactics. And using this, it improves itself and becomes stronger and stronger. So, and again, robotic dog learns the movement of its arms. So the robotic dog will learn by itself. Like if it doesn't properly move or properly coordinate, then it will fall. So it will learn by itself, like how to walk by interacting with the environment. So this is known as the reinforcement learning. So now we discussed supervised learning, unsupervised learning, and reinforcement learning. And now we will see two more fields of machine learning, two more important fields. One of them is computer vision. So what is computer vision? So it deals with mainly images, videos, and graphics. So it is a field of artificial AI and ML that enables computers and systems to derive meaningful information from the digital images, videos, and other visual inputs. So here you can see in the animation, uh, it first identifies different objects and then classifies them. So first in the boxes, it identifies that this is a car, this is a person, different food items are there. Then again, signals are also there. So yeah, so the computer tries to make sense of the images. The smart AI tries to make sense of what is first. It will identify the objects. Then it will identify the type of object. What is the type of object? As you can see in the animation. So we can see cars, we can see people, and all. So it first identifies them and it classifies them. So first, there are two main examples of computer vision. First is face recognition. So the AI can recognize our face, and then it can remember us. So face recognition is one main example, and another example is self-driving cars. So like self like Tesla. So in self-driving also, computer vision is used because the car should know what is in its surroundings, and it should identify people, identify different cars, identify the traffic lights, and using that only it can take a decision. So for that, it should get information from the visuals around it. From there are many sensors and cameras on the Tesla, and it gets data from it, and then processes the data, and then according to it, it tries. Currently, there is no fully autonomous car, but at least semi-autonomous cars are there. So, so using the computer vision technology, it it takes decisions and first tries to understand what are the images, what the images do. So this is a computer vision. And then next major field is NLP, or natural language processing. So what is NLP? So natural language processing is the ability of a computer program to understand the human language as it is spoken and written. So it tries to understand the human language, human text, human voice, uh, and all. So it comes under the category of natural language processing. But why is it important? Because there are many applications of NLP, and because the computer can, for the computer to understand, we need to program. It can't directly understand our language. So here in NLP, we try to make a model or AI that is intelligent enough to understand human language. So one such major application is information extraction. So here, suppose you have a long article or a long news article or some important study related article, and you have to get its summary. So you can design an NLP program to get a short 50 to 100 word summary of a long article. So for that, first it needs to understand the different words and what are the important words, important features, and then it needs to extract the features from the long article, and using that it can prepare a summary. So this is a very important example of NLP, like preparing a summary. And another example is sentiment analysis. Suppose you have been given a tweet and you want to know whether the tweet is positive or negative. So for that, you can use NLP program and use sentiment analysis. There are two major sentiments, positive and negative. So it will identify whether it is a positive tweet or a negative tweet. So this is again there it can also have many other sentiments like happy, angry, sad, and other sentiments. So this is mainly used by major companies to get their sentiment of the people about them. So what do the people think about their new products and all, and feedback. So for that, the companies analyze the tweets related to them using sentiment analysis. And again, another major example is translation. So we all are familiar with Google Translate. So Google Translate also uses different NLP algorithms to quickly translate. Nowadays, we can see that it is fairly accurate. Google Translate. So because it is accurate because of the advancement of NLP. So we can nowadays translate in all major languages using different NLP algorithms. And another example is a chatbot. So what is an intelligent chatbot? So what is a chatbot? Nowadays, you can see if you go to different websites and if you have some problem on customer care, if you go to customer care of different websites, you can see there is an AI chatbot, and you can talk to the chatbot. You can ask your queries, then it will direct you to different sections. So that is the role of an intelligent chatbot. So it answer. We feel like we are talking to a human, but actually we are talking to an algorithm, and it is smart enough to know. So it understands. So first it gets the information of what we need using our language, and then it processes it, and then it directs us to the right section, or solves our problem, troubleshooting and all. So so an AI chatbot, it is part of NLP. Now I will show you one animation. So this is an NLP ecosystem. So there are different types of NLP algorithms in work. So first, at the top left, so here a person is talking to a smart AI device. It looks like Alexa or Google Home. So it is. So first we can directly talk to us. Then so for what does the smart device does? So first it converts our speech to text. So first it identifies our speech, and then it converts it to text, then processes the information. So if you have asked the question like what time is it, so first it will convert it to text, then it will process it, then it will, yeah, since we have asked time, then it will give us a time. So it will give us the answer. So using all this involves NLP. Then again, it will recommend us different news articles. It can also give us the summary of different news articles. I already talked about the summary. So it can give us different short summary of different news articles for you. Then at the bottom left there is it can help us in smart recommendations. Like we just use some acronyms and it can type the full what is it like OMW, and here we can see on my way. And again at the bottom there is uh, it can be helpful in texting. Like if someone replies this is used in Gmail. Like if someone sends us a mail, then Gmail gives us smart recommendations, like what we can text them back. So like how about we meet, and then it says it gives us three options like sounds good, perfect, or I am busy. So it can just by looking at the text, it can process it and give us smart recommendations. So all this is possible because of NLP. And then the last one is about the captions. If you want to post an image or a video on social media, then and we don't know what caption should we put, then there are many websites nowadays that we can upload a picture and we can get a caption for it. So smart captions. So this is an NLP ecosystem. So so we just saw different uses of NLP here. So we saw NLP, computer vision, reinforcement learning, supervised learning, and unsupervised learning. So these were different algorithms here. You can see here unsupervised, supervised, reinforcement learning. If you now if you have any questions, you can write in the chat, or we can also take them at the end. Now whatever can continue.
Okay, am I audible?
Yes, Atharva.
So, hello, I'm Atharva. We will now discuss the two categories of supervised learning in detail. Supervised learning can be split into two subcategories: classification and regression. Classification is the process of predicting the class of given data points. It comes under supervised learning as we provide the data with labels. For a classification problem, the output variable will be a category, such as red or blue, disease or no disease, and spam or not spam. In this real-time example of classification, the dataset provided has both spam and regular mails. The model built is trained to classify an unknown mail as spam or not spam based on the data. As there are categories involved, this problem statement can be solved by a classification algorithm. Let's now move on to regression. Regression analysis is a form of predictive modeling technique which investigates the relation between dependent and independent variables and outputs the continuous variables or real values. A regression problem is when the output variable is a real value, such as dollars or weight. In this example, the model is trained based on the data of salary and experience. Now, for a new input experience, the salary can be predicted. Salary is not a category, but a real value. Therefore, this problem comes under regression. Now let's talk about Google Colab IDE, as we will be using it for tomorrow's coding sessions. Google Colab is a free notebook environment where you can create, share, and deploy your Python code. It runs fully on cloud, hence you can access and use it over the internet. To accelerate the processing, you can make use of Google hardware, which includes the free GPU and TPU. Now, what is a GPU? GPU or graphics processing unit is a specialized processor which can process multiple parallel computations simultaneously. This comes in handy when you process huge amounts of data, especially when training deep neural networks, and where it takes numerous hours to train on a CPU. Now, just like GPUs, TPUs or tensor processing units are also used to accelerate machine learning workloads. It is a highly optimized for neural network and are mostly used in case of multi-dimensional arrays. Now we will explore the Colab notebook environment. So as you can see, we'll now create a new notebook. Here we can change the name of the notebook. Now the Google Drive icon here signifies that the notebook you created is saved on a Google Drive. So you can access it directly from there. Here are the different tabs. This one's the runtime tab. Here you can either run the selected cell or run the complete notebook at once. There are three runtimes in Google Colab: none, GPU, and TPU. None is where you use the CPU. Okay, so we will switch to GPU. Here is the code block. You can start writing your code here. So we will write something. Now we can execute this code block either from here, or we can directly click on this icon. It first connects the notebook to the server. As you can see, it has successfully executed the code. Now we can add more code blocks by clicking on this button. We can also add text block. Now text blocks are used if you want to add some comments for the viewer to understand your code. So now you can write something like this, and here it gets printed. Okay, so now we will see how can we import data files in Google Colab. You can directly import it from the Google Drive, or you can go on this files option here, then this upload files button. Now I will import a CSV file named train. As you can see, the file is being uploaded. Meanwhile, we can import the libraries needed to work with these CSV files. So we will import the basic libraries. One is pandas, and we will call it as PD. So whenever we use this library to call the function, we will use PD instead of pandas. Now we can read the CSV file using the read function of pandas. Just copy the file path. And then we'll execute the entire code. Okay, so it has read the CSV file successfully. We can print the first few entries of the CSV file using the head function. So here it is. So this was a brief overview of the Colab notebook. You can always explore the other tabs and features. Before we end today's session, here's a problem for you all. Please read the question carefully and try to guess the correct option. We will discuss the solution tomorrow. Okay. So this was all from my side. Tomorrow we will delve deeper in ML as we introduce you to deep learning. We will also create simple machine learning models in a hands-on coding session. Thank you.
You can also ask your doubts now if you have any left doubts.
This is the starter landing page of Colab. You can create your notebook from here. You can refer these information to learn more about Colab. It would be helpful in tomorrow's coding sessions.